Hi, my name is Hugh, and this video we're going to take you on a tour inside the guts of the 8610 GC in terms of identifying circuit boards and all the actual things that you don't see when you look at the top of the GC. So, to get inside the GC, you need to remove the 6 screws that are holding the bottom plate on. I've removed 5 already, so this is the last one. So when all the screws are removed, you can tilt the GC up on its back and lower down this bottom plate so you can see all the hardware that's inside the GC. So this particular GC is fairly crowded. We can probably still fit a few more things in there, but there's a lot going on in this GC, so there's lots of different circuit boards because each circuit board controls some specific thing. Like these things here where the gases are connected are called electronic pressure control solenoids or modules, and they have to have a circuit board to read the pressure and then send the signal to keep the pressure constant. So it's a servo, and so there's a board here that controls 2 of these, and then there's another board here that controls 2 more, and there's a third board that controls the last 2. So there's 6 different gas controls on this GC because there's lots of different detectors, and each one needs a certain amount of this gas or that gas, so we have to control that very precisely with these things, and that's what these 3 circuit boards do. Then this circuit board provides a high voltage to ignite the photomultiplier tube, which is part of one of the detectors, and so that's the high voltage power supply for the photomultiplier tube. Then this board controls the temperature of the column oven, right? It tells it to cool down and heat up, and that's all that one board really does, is just control the column temperature. Then these 2 boards control various other heated places on the GC, heated zones. So there's 2 valves, so each valve gets a heater, and then there's 3 detectors, so each detector gets a heater, so that's 5 different other heated things that have to be temperature controlled, and that's what those 2 boards do. 3 on one and 2 on the other. Then this circuit board here is the amplifier board. So this particular GC has 1, 2, 3 detectors, so there would be actually no 4. There's 3 ionization amplifiers and 1 thermal conductivity detector amplifier. So there's 4 detector signals, and the detector signals go to the A to D board, which is this board here. This board is the one that the computer USB cable plugs into. So really this is the only microprocessor board in the GC. Everything else is analog circuitry, which is easy to repair in the event that, easy and cheap to repair in the event that it ever breaks, which it very rarely does. And then this last board here is what we call the 4 relay board. There's only 1 relay populated on this particular one, but it could have up to 4, and those relays are little mechanical things that touch each other, and that's how you would control maybe something else outside the GC under the control of the Peak Simple software that runs the GC. You can turn this on, turn that on, with whatever you need to do for your application. There's one more board, and that's called the display board, and that's this circuit board up here on the front of the GC where these black buttons are, right? So each GC, depending on what's inside, would have a different pattern of black buttons. So this board is kind of modular, lets us populate it any way that makes sense to control whatever happens to be installed in the GC. So that's where all the boards are. And then these objects here, these are the valve actuators. This GC has 2 gas sampling valves, but when they are in the GC, you can't really see this. This is up here in a heated oven, and this is buried in here. So those are those 2 valve actuators. And then this object here, this is the oven fan motor. This is what spins the fan in the column oven. And then there's a little fan to blow cold air on that motor because the heat, the oven can get up to 400 degrees centigrade. And of course, the shaft of the motor gets hot sitting there in that 400 degree heat. So it transfers the heat down toward the motor. So this tries to keep that shaft cool by blowing cold air on it constantly. And then there's another little fan here that circulates air around these pieces of aluminum where various electronic components that need a heat sink are mounted. So this acts kind of like a big heat sink. And then these tubes here are what we call the flow restrictors, right? So in this case, we have a hydrogen pressure controller, and the red tube, red is for hydrogen, so the red tube comes over to this side of the GC, and then it gets to a T fitting, and then it goes two places. So these tubes here are very small diameter inside tubes, so they restrict the flow of the gas, and that's how the flow is controlled. This sets the pressure. The restrictors set the flow because 20 psi of hydrogen results in 20 milliliters a minute going through that particular tube with a very small inner diameter. So that's how we control the hydrogen and air flows going to the detectors, is via these restrictors, and they just sit here. They're stiff. They're made out of stainless steel, so they just sit there like that. And then this is the built-in air compressor, right? This air compressor, it's expensive, but it's very quiet, which is the thing. Most air compressors are noisy. So this is a very quiet air compressor, and the air comes out here. It goes through a little filter like this, and then goes out the side of the GC, and then it comes right back in and goes to the two different air controls. So it's just it has a filter because occasionally this will generate a particle, and we want to keep particles out of the tubing if possible. So the filter catches any particles. It doesn't really clean the gas. It's just room air that is unfiltered room air, but that's perfectly fine 99% of the time. Okay, well, I think, except for the transformer here that takes the power and then makes lower voltages for various purposes, I think that pretty much covers everything inside the GC. So now you know all about it, and thank you for your patience.